All right, so if you find yourself at this video, hopefully it's because you've already done a bunch of momentum problems. You've done one-dimensional, you're pretty good at them. You've hopefully done one of the two-dimensional problems where the original object wasn't moving. And you'll notice that this time we're going to have the object moving before the explosion. So we have it moving at 12 meters per second in a west direction. It's an 8-kilogram object, and then it's going to explode into 3 pieces. We have 3 pieces. One of those pieces is going northwest, 125 meters per second, and it's 40 degrees north of west. We have the other known piece, which is going 100 meters per second at 50 degrees north of east. And then the question is asking you to find the mass and for you to find the velocity of that third piece. And I think your common sense would be correct in telling you that it's probably going south. But it's kind of hard to tell whether it's going to be going east or whether it's going to be going west. But it's certainly going to have some southward component to it. Okay, so let's get started. We know that before the collision, we have a known momentum that is west. And we know that that momentum is going to be 12 times 8, which is 96. And so we have 96 kilogram meters per second for the unit. And you'll notice that those units are units that are units for momentum. They are not units for velocity, and that's why we have a kilogram times a meter divided by a second, and not just meters per second. And this is crucial. To do these problems, the first thing you do is turn everything into momentums. Then you do the whole problem, all the components, all the canceling. You do all the problem in momentums. You do not go back to the velocities until the very, very end. Okay? So the whole problem is going to be done in momentum, even though the original question doesn't even mention momentum. Okay? But you recognize it as a momentum problem and that the only way to solve the problem is using momentums. Since we have a momentum to the west of 96 before the explosion, that means that after the explosion, we will also have a momentum of 96 to the west. Okay, that has to happen. We have no choices about that. That is going to happen, and we will make sure that it happens. Okay, the first thing we're going to do is work in terms of momentums instead of velocities. So that means that this 3-kilogram object here is going to have a momentum of 300 kilogram meters per second. We have this 50 degrees, and so I'm going to want my components. I need a component going to the east, and I need a component going to the west. Luca, you got those for me? Or not? We got to take, for example, we're going to take the sine of 50 degrees times 300. Okay, so we'll call that 230. Please realize when I'm doing these videos, I might do some rounding, and when you do it yourself, you're going to have slightly different numbers. That's okay. And then the easterly component should be a little bit less. We'll round that to 193. And again, these are all kilogram meters per second. I do get lazy sometimes and not write all those units down there, but they're all kilogram meters per second. So we have a 230 going north and a 193 going west. This one, 3 times 125, is going to be a 375, right? Kilogram meters per second. And this 40 degrees going this way means we're going to have these two components. Okay? So what do we get here? Again, using sine and cosine of 40 degrees and multiplying by 375. 287. Okay, so we have 287 going west, which we did use the cosine to get. And we're going to go with 241 for the north. Okay, and now we're ready to actually start the problem. And what I'm going to do is I'm going to pick the easier one first so I can get nice and warmed up. And of the two, whether we're choosing to go and talk about the north-south issues or we're going to choose to talk about the east-west issues, we've got to talk about those separately. And the easier one to talk about is the north-south issue. And the reason for that is because of our original momentum going to the west. Okay, makes that one a little trickier. North-south, so simple here. We've got a 241 north. We've also got a 230 north. And we know that in the original object, it wasn't moving north and it wasn't moving south. So that means that this third object has really got to be moving south a lot. Okay, so we're going to have a big southward component here. That's supposed to be straight down, and that does not look straight down. Let's try that again. So, a little better. In any case, it looks like we've got a 471. Okay, so we've got 471 kilogram meters per second. Okay, south for this third object. And it had to do that because it had to cancel the north momentums of the other two objects. East-west. We know that we need to be going west at 96. We have to be going west at 96. And that means that our other two, which is west at 287 and east at 193, should cancel to give me a 96 west. They do cancel, right? If you look at this, this gives us, looks like at about 94. Thank you. It gives us a 94 west. And so it almost is perfect. Okay, I made up these numbers and almost got it perfect, but it's not quite perfect. So we actually need a little bit more west. How much more do we need west? We just need two more. Just two. So we've got 471 south, and then I need this tiny little bit, just 2 kilogram meters per second west. Okay? And as far as the question's concerned, this is essentially going to be going straight south, but not quite, just slightly off. When you do Pythagorean theorem on this, don't be surprised that you get the 471 again. It's such a small angle that you're going to be getting almost exactly the same length for the hypotenuse. Okay, if you do that math, do you get about 471 again? Right, essentially the same. Okay, so we can still say this hypotenuse, and maybe if you get another sig fig in there, you might get something slightly bigger than 471. Okay, anybody want to throw a number at me? Okay, so it's essentially the same. Let's just leave it 471. The angle is going to be almost 0. It's going to be a very small angle as well. Anybody come up with an angle there? 0.24. Okay, so the angle's less than 1 degree, about 0.24 degrees. Just, we'd say, west of south. So we're essentially done with the problem. Remember that I said when we're done with the problem, stop and make sure if you're really done with the problem. Okay, the original question, if you recall, asked for velocity, and you'll notice at this point we found 471, but that was momentum, kilogram meters per second, right? And so to get to velocity, we're going to have to go ahead and say that velocity is momentum divided by mass. The mass, I think, was obvious to everybody. It was 2 kilograms. And so we get 471 divided by 2. And so we get a velocity that's approximately 235 meters per second. And we're going to say at 0.24 degrees or so west of south, essentially south here. So a little unfortunate choice of numbers because my east and my west almost exactly canceled to be exactly what I needed as far as this 96 that I had here. But in any case, that's how you do a two-dimensional problem when the original object is moving, and you'll have one of those on the quiz, and so be prepared for that next class. And good luck.